Okay, so now we are going to talk about um, a strange universe actually. Okay, so it's like a strange universe. So I mean, I'll let her give it a name actually. Okay, but let's call it a strange or interesting universe. So here is our universe. Okay, so I don't know how does it looks like. So maybe it looks like something like this. I don't know. Okay, and say I make a copy of it. Okay, and I make, for example, a copy of it and paste it here. So this universe is really what you call the strange universe. Okay. By the way, you can treat all of this discussion as really a thought experiment, actually. Okay. So as this strange universe apparently looks like precisely like our universe, actually. So as in our universe, we have, for example, lines, okay, or maybe the rigid objects that looks like straight, or maybe we have triangles, or maybe we have spheres, okay, and you have humans, maybe you have you know some kind of flowers, I don't know, so on and so forth. So in the strange universe, you have also something similar. So you have lines, you have triangles, you have, okay, spheres, you have, for example, humans, you have, I don't know, flowers, okay, and everything. So whatever exists here also exists here, actually, in this strange universe. And obviously you're going to ask the question, okay, this universe then up to this time like does not looks like anything strange here actually. So it's just a copy of um, our universe. But here is something that makes this strange universe really this strange one actually. So what makes the key thing as this strange universe different from our universe actually? The key thing that makes this you know universe, this strange universe different from our universe, is basically this: that let us assume that everything in this strange universe, say it's a line or a triangle or a circle or whatever, is made up of a special kind of elastic or maybe flexible rubber actually. Okay, so it's like made up of some elastic flexible rubber or material or anything. Okay, and in this universe, so since it is made up of say elastic or flexible rubber, so you can take an object, you can take any of the object in the strange universe, say triangle, line or whatever, and you can, for example, expand it as much as you like, okay, because it's made up of the elastic and flexible material. Okay, so you can expand it, you can shrink it, you can mold it, you can turn it, you can twist it, okay, the way you like. Okay, and you know doing all of these you know operations or transformations is not going to change. So if you take an object and expand it or shrink it or mold it or turn it or twist it, okay, so so it is not going to change So process of expansion, shrinking or molding, turning, twisting is not going to change the fundamental, okay, fundamental nature of object actually. Okay. So in other words, you take an object and you expand it, for example, or shrink it or mold it, so it would stay same. Okay, it would look like same actually, not look like necessarily, but we're gonna say that okay, essentially it's same. So let me show this through, for example, illustration. Okay, so here is our universe and here is a strange universe. Okay, so in our universe, there are things which are flexible. But everything is made up of, for example, different material actually. Okay, so if an object is, for example, if you have a piece of rod that looks like straight, okay, and you have a piece of rod, for example, that looks like parabolic, okay, or you have, for example, a spring, okay, they are all of these objects, for example, are different actually. Okay, you treat them different. But in the strange universe, okay, you can say, and it's not difficult to imagine actually that you can, for example, take this straight line or a straight object, since it is made up of extremely flexible elastic material, or maybe it's made up of some kind of special kind of rubber actually. So you can, for example, turn it actually, or maybe twist it, okay, mold it, okay, or maybe you can create, by turning or twisting it, you can create any kind of curve actually, okay, any kind of curve. I don't know, maybe you can, even if you create, for example, a spring out of it, and so on and so forth. So I can take, for example, this rubber object and and turn it and twist it. You can imagine in your head that like this is a broken rubber band actually. So you have a take a rubber band and cut it, for example. You have this broken rubber band. Then we know that we can put rubber band into any shape we like actually. Okay. So in the strange universe, okay, this is strange universe, all of these objects are really, what do you call, same actually. Okay, so a line is same as a parabola, is same as, I don't know, a curve is same as a spring, or anything that you can make out of, for example, um, this line. Okay, they all are same actually. Okay, this is straight rubber band actually. So they all are same. So you can do an experiment. You can take a piece of rubber band and just turn it, twist it, and create the new shapes of shapes by expanding it and shrinking it and so on and so forth. Okay, so they all are the same. Right. So what would be some, for example, other examples? Sphere. Okay, and so that's our universe. And you take, for example, a box. Right. If you take, for example, a box, right? Or you take, for example, pyramid actually. All right. Take pyramid, something like that. You know, these these all objects are different actually. We know that we treat them as different objects. If you ask from okay, this sphere and, for example, a box and a pyramid, they are different. So we can say that they are different actually. But in the strange universe, okay, in a strange universe, imagine that this sphere is made up of an extremely flexible material. Okay, and you, for example, shrink this sphere. So you're allowed to shrink this sphere actually as much as you like. Okay, so this would be still same. You can, for example, from this sphere, for example, by molding it and creating some corners out of it, I can turn it into what do you call a box actually. Okay, so I can create, for example, a box out of it actually. All right, so I can also create a box out of it, or maybe a pyramid, or maybe all kind of things. All right, all kind of things actually. For example, if you take a paraboloid, so ellipsoid actually. Okay, that's also really the same actually. Okay, so that's also really the same. All right, they all are. So these all objects are same. So you have to imagine in your head that okay, you can take a ball and you can press it and turn it and twist it in such a way that you can create all these shapes out of that actually. Okay, so since I can create these shapes out of, for example, from each other, so we're going to say that they are the same. Okay, um, um, what could be some other examples? Okay, so you can have lots of examples. Okay, you can have lots and lots of examples. All right, for example, um, it is in our universe. For example, we say that a circle and a triangle and you know a rectangle, okay, and maybe anything amoeba like actually, okay, they all are different actually. They all are different. Okay, so ellipses, they all are different. But imagine you have a rubber band. Okay, so you have a rubber band. So it's like a rubber band. Okay, and or maybe a circle. This does not look like a circle, but let's assume that it's a circle. Then you'll have this circular kind of rubber band actually. And then, for example, you put your fingers, 3 fingers here and here and here. Okay, and you stretch a bit actually. So what you can do, you can make a triangle out of it actually. Okay, or maybe if you stretch it from the 4 points, you can make, for example, a rectangle out of it, or you can stretch it and stretch it and shrink it and expand it in all kind of manners, and you can make all kind of closed, what do you call, figures actually. Okay, so in this strange universe, these all pictures would be what do you call, treated as um, treated as same actually. Okay, now let's give this strange universe a name. Okay, so this strange um, universe a name actually. Let's call it a topological universe. Okay, so topological universe. Whenever you think of a topological universe, think of a place actually where everything is made up of, you know, what do you call, made up of extremely elastic rubber actually. Okay, and in this, so here is really an intuitive, for example, a definition. Okay, that in this topological and strange universe, we would say that two objects, okay, are equivalent, okay, by distortions equivalent by distortions if you pick, for example, one object and apply, some expansion, expanded object, and by expanding, maybe a better way to say that, by expanding or shrinking or molding, I don't know, turning, twisting, turning, twisting. Okay, and let's put all of these, for example, operations in a single, what do you call, category. Let's call it continuously. Okay, continuously transforming. So when I'm saying that, okay, I'm taking an object and I have applied, for example, a continuous transformation on that object, and that continuous transformation is going to be kind of expansion, could be shrinking, could be molding, could be turning, twisting. You turn it, if you pick one object and by expanding or by applying continuous transformation, you turn it into what do you call second object, and vice versa. All right? Vice versa. So you're going to say that, okay, these two objects in the strange universe are equivalent by distortions actually. So what are the distortions? So distortions are these continuous transformations actually. Okay. So now I would like to pose two challenges actually. So here is one interesting challenge. It's called the ring challenge actually. Okay, it's like a ring challenge, and obviously you're going to assume that, for example, that we are in a strange universe. Okay, and let me put the picture. Or maybe put the picture of in this pictorial form. So imagine imagine you are in this uh, strange universe. Okay, and you have, for example, so obviously you have a ring actually that is made up of the flexible material. You have, for example, this piece of rubber or piece of paper made up of the flexible material, and the ring is passing through the two holes actually. Now you are allowed to do any of these transformations, that is expansion, shrinking, molding, turning, twisting. Okay, maybe doing the continuous transformation. Can you think of a way of turning this, ring which is going through two holes? Can you turn and twist, for example, this picture or maybe the piece of rubber, and in such a way that the ring just stays in one hole actually? Okay, like this seems a bit impossible in our kind of universe actually, but is it possible or not possible to do the same in what do you call in the strange universe actually? So that's really is the first challenge that you have to think about actually. So here's the second challenge actually. Can you the second challenge is to basically consider these two shapes actually. So one looks like, for example, a donut actually, or maybe two donuts put together, and one is basically this entangled, picture actually. Okay, take this picture and do some transformations into it, do some distortions, obviously continuous distortions, okay, into it, and turn it into, for example, such a picture actually. All right. Keep in view, you are only allowed to do, the continuous transformations actually. So you can expand any part of this picture you like. You can shrink it, you can mold it, you can turn it, you can twist it. Okay. but you can't add anything from outside. Okay, so there are, as you have continuous transformations, so there are also what do you call, um, uh, what do you call discontinuous uh, transformations actually. Okay, so what are discontinuous transformations? Okay, so these are the transformations. Uh, it's like adding, or gluing, okay, two parts of the objects, or maybe breaking or removing some parts of it. So these are the discontinuous transformation. So in order to do these both challenges, you're not allowed to add anything, you're not allowed to glue anything, you're not allowed to break or remove anything. Okay, you just have to, think your imagination and expansion, shrinking and turning, twisting to turn, like for example, this picture into this, and to turn, for example, this, entangled picture into what you call donut actually. Okay, so, give it a go, give it a think actually.